Hi everyone. Uh, I'm Avi Marcus. I'm from the editor group, and this is putting the R in R&D. Uh, it's called R&D. We have a VP R&D, but let's face it, we're not that good in the R part. We mostly skip over it, and I want to try and change that. So first, we'll start with the definition. What the hell is research? I'm a developer. Why should I research? Research is from the word search, surprisingly. And it's the process where you decide what the hell you're going to write. And we all do it. It happens mostly without our noticing. And we search what the hell we're going to write. We have a spec, we have a requirement, we have a bug to fix. It doesn't really matter. In the end, we have some notion of what we want to achieve, and we have a code base, or maybe not if we're starting from a greenfield project, and we want to get somewhere. And the R part is deciding how we're going to get from where we are to where we want to go. And the point about the search part is you take a lot of small steps in random directions, sometimes not that random, hopefully not that random. But in the end, you pick a direction. And then you apply, you do the D part, which we're really good at. And the only problem is we often apply a lot of D in the wrong direction, and we waste a lot of effort. The path to 10x. That's the mythological creature, the 10x developer. Everybody talks about it. Yeah, there's blog posts from here to the end of the world talking about it. And the 10x developer doesn't write 10 times as much code. It doesn't write more tests. It doesn't write it faster. He just picks the right direction to work at. And that picking the right direction is the difference between progressing really, really slow and reiterating and deleting and working over stuff and actually progressing in a nice pace and delivering deliverables and changing the business and doing stuff that matters. And the problem is most of us view research as the other guy's problem. It's the core 3 people, they're supposed to do the research, or there's the architect, he'll do it, or the team lead. That's not the way it works. Research is what each and every one of us does every day, every time he opens, or she opens the Jira and decides how they're going to write the next feature. They're doing research. They're just not noticing it. And if you want to get to 10x, the answer is really simple. Instead of having small isolated bubbles of research, we need everyone to do it. I'm not that good at drawing, but that's supposed to be purple. So research is about search. And we know search algorithms. We write them, we interview people and ask them to write them for us. But we don't apply it to our craft, and that's sad. So I'm going to go over a few search algorithms with you and try to figure out what we can take from them and apply to our craft and how to get better at it. This is actually a search algorithm that tries to recreate the Mona Lisa by mutating 50 triangles. And each time it compares the pixels one by one and sees if it got a little closer to the Mona Lisa. And if it did, that's the next baseline. And that's what will mutate next. A lot of our work on big code bases is exactly like that. We try to mutate small things. We go about it pretty much blindly. And in the end, it works. But we throw out a lot of CPU cycles, and I'm talking about those in your head, not in the box next to you. So what are the key parts of a search algorithm? Every search algorithm has 2 parts. An evaluation, where it tries to decide if the current state is good enough or not. And an iteration, where it decides what's the next thing to evaluate. That's all search algorithms you've ever encountered have these two parts, and that's what they do. The good news is we're really, really good at the evaluation part. And the reason we're really good at it is whether we want it or not, we get instant feedback when we're wrong. Every time we make a mistake, take a wrong shortcut, think about the wrong abstraction, we get feedback. If you work on a code base and you made the wrong choice, it will come and bite you in the ass. And that pretty much means that as you grow more experienced, your algorithm for evaluating an idea will get better. So, okay, we're pretty good at evaluation. The only problem with evaluation is that we're sometimes missing context. If you're looking at your tasks through a pinhole, because the tasks are like 2 story points in Jira and every task is tiny, you sometimes miss the big picture and you don't evaluate how that affects the grand design. Sometimes you don't even know what the goals are for the next year or two. And that's a problem. And the other part is, because we're this big, this is a big crowd, we have knowledge silos. Like, not everyone knows even the basic stuff about what other people in the company are doing. And that causes you to miss stuff, like the gatekeeper adds a new set of requirements and your features are not compatible. You need to think about it and things like that. But pretty much, we're pretty decent at evaluation. Where we fail is the iteration. And to iterate properly, it's knowing when to stop. It's selecting what the next thing you're going to evaluate is and doing it as fast as possible. So knowing when to stop. If you look at any search algorithm that min-max tries, I don't know, a computer program tries to play chess, and it can't evaluate all the possible states in the board. It allocates a certain amount of time and says, okay, this is the best move I found. After 3 seconds, I'll play my move. And that's one approach. And the other one is when you can't improve anymore. If you tried enough stuff and you're not getting any idea that is significantly different, significantly better, then perhaps it's time to stop. When is it not time to stop? When it's your first idea. And that's what most of us do. That's what I do. And we need to stop it, because good enough is not good enough. I've heard people say, yeah, we'll hire a team and 5 developers and a team leader, and they'll implement that. And that's usually not the answer. If your best idea is to throw 5 man-years at a problem, then most of the time you need to go back, think of some more, and try to find a better approach. If we were in a tiny startup, we wouldn't have hired 5 people and told them to implement something. We would either table the feature until we have a better idea, or kept thinking and finding a better solution. The problem with having so much resources is that we can actually afford to hire 5 people and a team leader and have them work at the feature. And the problem is this stuff accumulates. It's the more code you have and you go slower. And a lot of it is trying to not go slower. Okay, this is, I had to put this one in. It's where I tell you to eat your carrots and your peas. Basic research. If you're implementing a file system, you should read up on how file systems are implemented. It's like there's a ton of shortcuts and a ton of knowledge out there. And you don't need to know it all by heart, but it helps that if you're assigned a feature, you should at least browse through the history of the mistakes other people did so you can learn from them. And basically, this is about finding the shortcuts without having to endure the path yourself. Okay, binary search, it's our favorite search algorithm. Why is binary search faster than a linear search? It's really simple. It's because of something in information theory you call information gain. It's because you discard half the solution space whenever you evaluate a candidate. And that's when you need to consider when you're evaluating ideas. It's, am I going to learn how to choose better from the next idea based on the result of this one? If I'm running an experiment, will a certain answer tell me, no, this is the right direction or this is the wrong direction, and enable me to eliminate half the possible space? And that's what we want. We want to eliminate the space of possibilities as much as we can, as fast as we can, so we can choose better. BFS, another popular. How do you make BFS faster? You go backwards. You go from both the start and the end at the same time. That's what we need to do. If you have some idea of what the perfect solution would be, instead of trying to get to it, you work back from it. It's like, my perfect solution for most problem is writing myself out of the equation. If I'm writing something, I don't want to have to be the one that maintains it. And that dictates a lot of decisions you have to make. And it's usually a lot easier to go backwards from perfection than slowly trying to get to it. Anybody know what this picture is? Silence. Okay, this is the Gossamer Albatross. It's the first plane that is human-powered that crossed the English Channel. 1959, some millionaire puts up an X Prize, like 5 million of today's dollars, for the first person to build an airplane powered only by human muscles that crosses the English Channel. It's a lot of money. It's an interesting problem. Many, many teams tried. It took actually 18 years for that whole thing to be invented. And the person who invented it realized something. It's every team that tried took like 6 months, built this huge plane, and it crashed. And then maybe if it had enough money and vision and patience, they did another try, and that one crashed too. What Paul McGreedy realized is he needs a way to fail a lot faster. He needs to be able to iterate faster. So instead of trying to invent a way to fly across the English Channel, he tried to invent a way to build an airplane he can rebuild in a few hours. And a couple of months later, he actually flew the channel. And that's what we need to do. We need I know in computer science class they tell you that complexity is the end-all, be-all. If something is ON or O1, it doesn't matter what multiplier you multiply it by, but in the real world, in search, it matters. And we need to search faster. And to search faster, there are two approaches. There's the guy who invented closure, Rich Hickey, has a phrase that I like, hammock-driven development. It's when you step away from the computer, step away from the keyboard, and think. You're not allowed to type anything. You're not allowed to test anything. It's about being in the hammock and thinking, trying to find a better solution. Any solution you can eliminate in your head is probably at least 100 times faster than the time it takes you to eliminate it in IDE or Codebase. Or failing that, if you have to do something on code, we need to experiment, we need to POC, we need to hack. actually ran a search in GitHub and tried to find how many commits are there with the words POC or hack or something of the sort. And I think I found like 1,000. About half of them were mine, which is kind of sad. And if we'll throw more code away, we'll have a lot better velocity, and we'll write the features a lot faster, and it will be a lot less pain to maintain them later. So this is where I tell you what I told you. It's basically, if you want better results, it's not about hiring more people. It's not about improving our onboarding of developers. No, it's about having better research. And we're really good at the evaluation part. We're really bad at the iteration part. We usually stop on the first one, which is not a very good idea. We need to throw a lot more code away. We need to hack. Once somebody told me there are no hacks at Wix, and that's really sad. I'm okay with very few hacks getting to production, but no hacks at Wix just means we're slow. And always try to think back from the optimal solution. Thank you.